The question related to topic circular motion, you may find some of the questions are from different topics, so we'll skip those right now, and later we will come back to those uh, parts because like some of the question might be related to the simple harmonic motion, so we'll skip in that case. In the question, a steel sphere is there of a mass 0.29 kilogram, is suspended in equilibrium from a vertical spring. The center of the sphere is 8.5 centimeter from the top of the spring. So you can see here. And the mass is given the position of a center from the point where it is hanged, that is also shown. The sphere is now set in a motion so that it's moving in a horizontal circle. Like this is moving in a horizontal circle, and the angle with the vertical is 27 degrees with a constant speed as shown. The distance from a center of the sphere to the top of the spring is 10.8. So this distance is given to us, that is 10.8 centimeter. Explain with reference to the forces acting on the sphere why the length of a spring in figure 2.2 is greater than figure 2.1. So the spring originally it was having an object which was stationary, and now this we set up this spring and it is undergoing or it undergoes a circular motion. So as it undergoes a circular motion, there will be force which is acting. There will be a force which is acting towards the center, which we call a centripetal force, and weight is acting downward. When it was not moving, like example, we just hang the object. When we just hang the object, so what will be the weight was acting downward and tension was there acting upward. So in that case, the weight was balancing with the tension. But now, as it is in a circular motion, which is making certain angle with the vertical axis. So if I say this is a tension T is there, so this T will have the two component. One is with an angle, another one is opposite to the angle. So the component which is with an angle, that is equals to, if you take this angle as a 27 as well, so this tension will have the two component. One is with an angle, so when it, with an angle is T cosine theta, or that will be T sine 27. And another, sorry, with this is opposite to the angle, this is with an angle. So with an angle, so this will be equals to T cosine theta. And another one is opposite to the angle, so that is equals to T sine. See, there's a force on this, or we can say a tension is there. Initially, when the spring was there, the weight which was acting downward balances with the force of the spring, and W is equals to F. But now, as it is rotating in a circular, undergo a circular motion, so this will have the two component. Weight is already acting downward, but now if there was a tension in the spring, this angle is 27. So if this was T, one of the component is with an angle. So what is this component? So that is equals to T cosine theta or T cosine 27. And another component is there which is equals to T opposite to the angle. So that is T sine 27. Now, as what will be the effect of these two components? That one force, like there is also now a downward force is there of a T cosine or a tension is there. So weight is already there and there's another downward component. So what will happen to the overall downward component or overall component that will increase? So this object is moving in a circular path, there's a force which is directed towards the center. So as you can see, the horizontal and the vertical component of the forces will combine together, which will result in a greater force on the spring. So it's like there's a force toward the center and the weight is acting downward. So as a result, what will happen? And this is a force by which it is pulling it, because this is a force by which it pull. The weight is acting downward, and there should be a component which is opposite to the angle. So they will also have a result, and resultant of these two combined together, like the resultant of these two will combine together, that will produce a greater force on the spring as compared to when the spring was vertical. When it was vertical, only weight was acting downward and there was a force of the spring acting upward. So we say W is equals to F. But when it is moving in a circular path, it will have the component as well. Like example, there is a force which is directed towards the center and there is a weight acting downward. So collectively or combined together, they will produce more force, like their resultant will be more. And as a result, when the resultant is more, the force on the spring will be greater. So it will have a greater extension. Is it clear, this one? So if I want to resolve into the components, look, this is a force of the spring. This force of the spring, because the spring will try to pull it. So this force of the spring will have the two components. This angle is 27. So this is equals to F cosine 27. And this is equal opposite to the angle is equals to F sine 27. So now the tension is what? The tension is a combination. Like if this is F, the force, and it is having two component F cosine 27 and F sine 27. So this will have because two component combined together to give this F. As compared to the first one, when force F was there and a weight was acting downward, they were balancing each other. But now the horizontal and vertical component combine together to give a force on the spring. That is why if the force on the spring is greater, it means it will have a greater extension, because force is directly proportional to extension. Any doubt in this?
No, sir.
So this will be the force of the spring, which will be a combination of F cosine 27 and F sine 27. So the spring was actually horizontal,